Hey everybody, welcome to part 2 of my ISLM series. In this one, I use the Keynesian Cross model to actually build the IS curve, the investment savings curve. So here's what I'm going to do. I'm going to show how a planned investment change affects the Keynesian Cross model, and then we're going to then make investment be a function of R, so it'll become endogenous. In the last video, it was always exogenous. And I'm going to show the IS curve graphically, and I'm going to show you how to solve for and derive the IS curve. So first, let's get back to our Keynesian Cross model. There it is, planned expenditures, and then the 45-degree line where y equals planned expenditures. If you decrease I, don't forget, planned expenditures is C plus I plus G, so if you decrease planned investment, you'll decrease the planned expenditures curve and go to a lower GDP. By the way, all that multiplier stuff, if you change the spending multiplier in the last, if you change G in the last video, you can solve for how much GDP changes by. Same idea applies here. The same spending multiplier works. Anyway, if you increase I, that increases the planned expenditures curve, which raises GDP. Okay, so for an example, I'm going to use the same numbers that I start with in part 1. Same consumption function, half times y minus t. Investment starts at 450, g at 500, t at 400. And from part 1, don't forget, our planned expenditures curve was half of y plus 750, which is 0.5y equals 750 when you set it equal to y. And y1 was 1500. So that was our GDP starting out. Now let's go to the increase in investment, and so the new level of investment is 600. Well, then our planned expenditures curve, by the same reasoning from part 1, will go to 0.5y plus 900, because it went up by 150, so from 750 to 900. Y equals 0.5y plus 900, that's the equilibrium condition. 0.5y equals 900. Y is then equal to 1800. We raised investment and GDP rose by more. Now, that was all just kind of like, hey, wake up and remember this stuff. Moving investment around shifts the planned expenditures curve. So now let's allow investment to be endogenous. We're going to make it depend on the interest rate. So, planned investment is equal to 1,000 over R. Just as an example, you could do any I of R you want. Now, if R equals 4, then planned investment equals 1,000 over 4 is 250. Then if R is 5, planned investment is equal to 1,000 over 5, which is 200. It depends on R. R changes, planned expenditure will change because planned investment is changing. For example, here we are starting out. Planned expenditure 1, Y1, and now let's see what happens when we lower interest rates. So R2 will be lower than R1, and R3 will be lower than R2. Well, if you lower the interest rates, investment will rise, planned expenditure will rise, GDP will rise. If you lower the interest rate further, planned investment will rise, GDP will rise, and there you go. So that picture, I actually copy-pasted it, just relabeled it, is the same as this picture. When we change our interest rates, it will change investment. Only now, instead of it having to be this exogenous change in I bar, we're letting the interest rate be flexible and investment will respond to it. So for instance, what if R1 was 5, and R2 was 4, and R3 was 3? Well then, planned investment with the first interest rate is 200, which means our planned expenditure curve is 0.5y plus 500, which means our equilibrium condition looks like this, which means y1 star equals 1,000. If we have the second interest rate of 4%, 1,000 over 4 is 250, so there's our new planned investment, which gives us this planned expenditure curve, 0.5y plus 550. Notice investment went up by 50, and so the planned expenditure went up by 50. Here's our new equilibrium condition, and you'll get y2 star equals 1100. For the third interest rate, 1,000 over 3 is 333. There's your new planned expenditures curve, and there's your new GDP, 1266.6s. All right, so here it is again. Same picture, and now we got 1,000, 1,100, and 1266.6s. Different interest rates, 543, leading to higher and higher GDPs. So now let's actually build the IS curve, the investment savings curve. We're going to take this GDP all the way down. It's going to be the same GDP in both. This is why we always stack it vertically, to remind us that it's the same GDP numbers. Now I'm going to look and remember that the blue GDP, GDP1, was linked to a 5% interest rate. And so I plot 5% interest rate on that GDP. Then I go to the next point, 1,100. And that was linked to a 4% interest rate. And so there we are. And the next one, 1266, linked to a 3% interest rate. And there we go. Link these things together, you've got an an investment savings curve. It's telling a very similar story, except instead of having planned expenditures on this axis, we have interest rates on this axis. Interest rates are something that we're often interested in measuring, comparing, setting policies about it. So this thing is very helpful to us. It tells us our predicted GDP as a function of interest rates. Now let's go back to this. Y equals C plus planned investment plus G. Only now investments are. If you want to solve for the IS curve, just solve for R. It'll be a function of Y, but solve for R and you'll get your IS curve. Okay, so you have R on the vertical axis, that's what we solve for. So IS is some R of Y. Let's look at it with this specific example and then we'll be done. Y is equal to C plus I plus G. Okay, solve for R. Y minus 0.5y plus T minus 0.5 T bar minus G equals 1,000 over R. Solve for everything. You get IS equals R of Y is 1,000 minus all that stuff that was on the left-hand side. That's a function. R as a function of Y. That is the function for this IS curve that we drew a sketch of. Let's check and make sure it works, just for fun. We knew that with a 5% interest rate, GDP should be 1,000. So let's plug everything in. 1,000 divided by 0.5 times 1,000. That's the part we're plugging in. Minus plus T bar of 400, all minus G of 500. It's 1,000 over 700 minus 500. That's 1,000 over 200, which is 5. Booyah. It works. Now, I can mess with this. I can do all kinds of crazy stuff. But the gist of it is you take your Y equals C plus I plus G, solve for R, and you'll get your investment curve, your IS curve. So yeah, guys, I hope that's helpful to you. If not, too bad. Good luck anyway. Thanks for watching, and happy eating.